3 positive predictions for 2025. First prediction: AI will help develop new medicines. Progress in computational technologies is often described by Moore's law, an empirical rule stating that the number of transistors on a silicon chip doubles approximately every 2 years. However, the pharmaceutical industry has been progressing in the opposite direction. Its own rule, known as Eroom's law, Moore spelled backward, states that the cost of developing a new drug doubles roughly every 9 years. In the 1960s, $1 billion invested in research and development could produce around 10 new drugs. By 2024, that amount is insufficient even to create one. On average, developing a new drug takes about 10 years and requires over $2 billion in investments. The risks are also extraordinarily high. Fewer than 10% of drugs that enter clinical trials gain regulatory approval. However, experts in AI argue that it can accelerate and reduce the cost of drug development, benefiting both pharmaceutical companies and patients. In 2025, with a new wave of drugs approaching approval, AI will begin to deliver on these promises. Drug development starts with identifying a target, a protein or gene associated with a specific disease. Scientists then search for a molecule that can block or enhance its activity. After identifying promising molecules, they are tested for safety and efficacy, first through computer models and then on animals. Up to 1 million compounds may be tested in the preclinical phase, with 1 or 2 candidates advancing to further studies. This stage can take years and accounts for nearly a third of the total cost of drug development, even before human trials begin. At the preclinical stage, AI becomes a crucial tool for pharmaceutical researchers, increasing their chances of success. First, it helps researchers better understand diseases and their targets by analyzing vast datasets. Second, AI identifies the most promising molecules and fine-tunes their structures, increasing the likelihood of success in clinical trials. Generative models can go even further, creating entirely new molecules for testing. An example is AlphaFold 2, a model developed by DeepMind, a subsidiary of Google, which astounded the scientific community in 2021 by accurately predicting the structure of nearly all human proteins. In 2024, its successor, AlphaFold 3, extended its capabilities to DNA, RNA, and ligands. These advances significantly reduce the time and cost of experiments. Tasks that once took months can now be completed in hours. Second prediction: cancer vaccines will emerge. After decades of setbacks, efforts to develop vaccines capable of stimulating the immune system to fight cancer have begun to yield promising results. A breakthrough may occur as early as 2025. This optimism stems from advances in mRNA technology and personalized medicine, particularly the melanoma vaccine known as mRNA-4157, developed by Moderna and Merck, which is showing successful trial results. Third prediction: a new publicly available energy source will appear. By the end of 2025, the Spark fusion reactor designed for commercial-scale operation is set to launch with a planned output of about 140 megawatts. It is being developed by Commonwealth Fusion Systems, a company spun out of a Massachusetts Institute of Technology project. Spark is a tokamak, a device with a toroidal reaction chamber surrounded by powerful electromagnets. These magnets contain and heat plasma made of hydrogen isotopes, deuterium, and tritium. At high temperatures, they undergo fusion, releasing helium, neutrons, and vast amounts of energy. According to the Fusion Industry Association, as of 2024, about 40 companies had raised a total of $7.1 billion to work on nuclear fusion. Some of these companies use alternative approaches. For instance, the Canadian company General Fusion plans to compress and heat plasma in liquid metal cavities. A test reactor using this technology is also expected to launch in 2025. Thermonuclear fusion, a type of nuclear reaction in which light atomic nuclei combine into heavier ones due to the kinetic energy of their thermal motion, promises humanity access to virtually limitless energy free from greenhouse gas emissions and toxic waste. However, mastering this reaction has eluded scientists for over 60 years, despite extensive and costly research. Thank you for watching. Subscribe to our channel and remember, the best way to predict your future is to create it.